not to be confused with tool and die. Taps and dies are cutting tools used to create screw threads, which is called threading. A tap is used to cut the female portion of the mating pair. A die is used to cut the male portion of the mating pair. The process of cutting threads using a tap is called tapping, whereas the process using a die is called threading. Both tools can be used to clean up a thread, which is called chasing. History: while modern nuts and bolts are routinely made of metal, this was not the case in earlier ages, when woodworking tools were employed to fashion very large wooden bolts and nuts for use in winches, windmills, watermills, and flour mills of the Middle Ages. The ease of cutting and replacing wooden parts was balanced by the need to resist large amounts of torque, and bear up against ever heavier loads of weight. As the loads grew ever heavier, bigger and stronger bolts were needed to resist breakage. Some nuts and bolts were measured by the foot or yard. This development eventually led to a complete replacement of wood parts with metal parts of an identical measure. When a wooden part broke, it usually snapped, ripped, or tore. The splinters having been sanded off, the remaining parts were encased in a makeshift mold of clay, and molten metal poured into the mold, so that an identical replacement could be made on the spot. Metalworking taps and dies were often made by their users during the 18th and 19th centuries, using such tools as lathes and files for the shaping, and the smithy for hardening and tempering. Thus builders of, for example, locomotives, firearms, or textile machinery were likely to make their own taps and dies. During the 19th century the machining industries evolved greatly, and the practice of buying taps and dies from suppliers specializing in them gradually supplanted most such in-house work. Joseph Clement was one such early vendor of taps and dies, starting in 1828. With the introduction of more advanced milling practice in the 1860s and 1870s, tasks such as cutting a tap's flutes with a hand file became a thing of the past. In the early 20th century, thread grinding practice went through significant evolution, further advancing the state-of-the-art of cutting screw threads, including those of taps and dies. During the 19th and 20th centuries, thread standardization was evolving simultaneously with the techniques of thread generation, including taps and dies. The largest tap and die company to exist in the United States was Greenfield Tap and Die of Greenfield, Massachusetts. GTD was so irreplaceably vital to the Allied war effort from 1940–1945 that anti-aircraft guns were placed around its campus in anticipation of possible Axis air attack. The GTD brand is now a part of Whittier Products Group. Tap. A tap cuts a thread on the inside surface of a hole, creating a female surface which functions like a nut. The three taps in the image illustrate the basic types commonly used by most machinists: bottoming tap or plug tap. The tap illustrated in the top of the image has a continuous cutting edge with almost no taper. Between 1 and 1.5 threads of taper is typical. This feature enables a bottoming tap to cut threads to the bottom of a blind hole. A bottoming tap is usually used to cut threads in a hole that has already been partially threaded using one of the more tapered types of tap. The tapered end of a bottoming tap is too short to successfully start into an unthreaded hole. In the US, they are commonly known as bottoming taps, but in Australia and Britain they are also known as plug taps. Intermediate tap, second tap, or plug tap. The tap illustrated in the middle of the image has tapered cutting edges, which assist in aligning and starting the tap into an untapped hole. The number of tapered threads typically ranges from 3 to 5. Plug taps are the most commonly used type of tap. In the US, they are commonly known as plug taps, whereas in Australia and Britain they are commonly known as second taps. Taper tap. The small tap illustrated at the bottom of the image is similar to an intermediate tap but has a more pronounced taper to the cutting edges. This feature gives the taper tap a very gradual cutting action that is less aggressive than that of the plug tap. The number of tapered threads typically ranges from 8 to 10. A taper tap is most often used when the material to be tapped is difficult to work or the tap is of a very small diameter and thus prone to breakage. The above illustrated taps are generally referred to as hand taps, since they are, by design, intended to be manually operated. During operation, It is necessary with a hand tap to periodically reverse rotation to break the chip formed during the cutting process, thus preventing an effect called crowding that may cause breakage. The most common type of power-driven tap is the spiral point plug tap, whose cutting edges are angularly displaced relative to the tap center line. This feature causes the tap to continuously break the chip and eject it forward into the hole, preventing crowding. Spiral point taps are usually used in holes that go all the way through the material, so that the chips can escape. Another version of the spiral point plug tap is the spiral flue tap, whose flutes resemble those of a twist drill. Spiral flue taps are widely used in high-speed, automatic tapping operations due to their ability to work well in blind holes. Whether manual or automatic, the processing of tapping begins with forming and slightly countersinking a hole to a diameter somewhat smaller than the tap's major diameter. The correct hole diameter may be determined by consulting a drill and tap size chart, a standard reference item found in many machine shops. If the hole is to be drilled, the proper diameter is called the tap drill size. In lieu of a tap drill chart, it is possible with inch-sized taps to compute the correct tap drill diameter as follows. Whereas the tap drill size is the major diameter of the tap, and is the thread pitch. For AAA-16 tap, the above formula would produce 5/16 as a result, which is the correct tap drill diameter for AAA-16 tap. The above formula ultimately results in an approximate 75% thread. The correct tap drill diameter for metric-sized taps is computed as, whereas the tap drill size is the major diameter of the tap, and pitch is the pitch of the thread, and so the correct drill size is 8.5 ohm. This works for both fine and coarse pitches, and also produces an approximate 75% thread. With soft or average hardness materials, such as plastic, aluminum or mild steel, the common practice is to use an intermediate tap to cut the threads. If the threads are to extend to the bottom of a blind hole, the intermediate tap will be used to cut threads until the point of the tap reaches bottom, after which a bottoming tap will be used to finish the hole. Frequent ejection of the chips must be made in such an operation to avoid jamming and possibly breaking the tap. With hard materials, the machinist may start with a taper tap, whose less severe diameter transition reduces the amount of torque required to cut the threads. If threads are to be cut to the bottom of a blind hole, the taper tap will be followed by an intermediate tap and then a bottoming tap to finish the operation. Machine tapping. Tapping may either be achieved by hand tapping by using a set of taps, first tap, second tap and final tap, or using a machine to do the tapping, such as a lathe, radial drilling machine, bench-type drill machine, pillar-type drill machine, vertical milling machines, HMCs, VMCs. Machine tapping is faster, and generally more accurate because human error is eliminated. Final tapping is achieved with single tap. Although in general machine tapping is more accurate, tapping operations have traditionally been very tricky to execute due to frequent tap breakage and inconsistent quality of tapping. Common reasons for tap breakage are, tap-related problems, wearing of tap cannot be easily quantified, use of tap with improper tap geometry for a particular application, use of non-standard or inferior quality taps, clogging with chips, misalignment between tap and hole, over or underfeeding the tap, causing breakage in tension or compression, use of improper and or insufficient cutting lubricant, absence of a torque limiting feature, improper or zero float for use with screw machines, improper spindle speed. In order to overcome these problems, special tool holders are required to minimize the chances of tap breakage during tapping. These are usually classified as conventional tool holders and CNC tool holders. Tool holders for tapping operations. Various tool holders may be used for tapping depending on the requirements of the user. Aids for hand tapping. The biggest problem with simple hand tapping is accurately aligning the tap with the holes so that they are succially, in other words, going in straight instead of on an angle. The operator must get this alignment rather close to ideal in order to produce good threads and avoid tap breakage. The deeper the depth of thread, the more pronounced the effect of the angular error becomes. With a depth of 1 or 2 diameters, it matters little. With depths beyond 2 diameters, the error becomes too pronounced to ignore. Another fact about this alignment task is that the first thread or two that is cut establishes the direction that the rest of the threads will follow. In other words, you can't make corrections to the angle once you have cut the first thread or two. To help with this alignment task, several kinds of jigs and fixtures can be used to provide the correct geometry without having to use freehand skill to approximate it. Hand tapper, a simple fixture analogous to an arbor press in its basic shape. Its spindle is thus held accurately perpendicular to the work. Standard taps are held in the spindle, and the operator turns the spindle manually via a handlebar. This fixture obviates the need for the operator to carefully and skillfully approximate perpendicularity, which even for a skilled operator can easily result in a 2 degree error. Tapping guide, or tap and reamer aligner holder, a simple conical guide slipped over a tap when using a regular tap handle. As with a hand tapper, the basic principle is simply that of a jig or fixture to provide the correct alignment. Heads for machine tool spindles, tapping attachments, these may be normal or quick change drilling and tapping chucks, rigid tapping attachments. Generally the following features are required of tapping holders: twin chucking, tap is held at points of both its circular and square cross-section. Gripping the circular section assures concentricity to the machine spindle, and gripping the square produces positive rotational drive. Safety clutch, the built-in safety mechanism operates as soon as the set torque limit is attained to save the tap from breakage. Float radial parallel, small misalignments are taken care of by this float. Length compensation, built-in length compensation takes care of small push or pull to the spindle or feed difference. Tapping case studies with typical examples of tapping operations in various environments are shown on sourcemechanicshallade.com. 1. Tapping stations. Tapping stations are work tables with a tapping head attached to the end of a pantograph-style arm similar to that of a balanced arm lamp. The operator guides the tapping head to each hole and quickly taps it. Drilling and tapping centers, whose name sounds similar to that of tapping stations, are actually light-duty, affordable machining centers of 2, 2.5, or 3 axes that are designed for a life of mainly drilling and tapping with limited milling use. Tap drill sizes. Die. The die cups a thread on a preformed cylindrical rod, which creates a male-threaded piece which functions like a bolt. The dies shown are, top left, an older split die, with top adjusting screw, bottom left, a one-piece die with top adjusting screw, center, a one-piece die with side adjusting screw, right, two dies with side adjusting screws, a cylindrical blank, which is usually slightly less than the required diameter, is machined with a taper at the threaded end. This chamfer allows the die to ease onto the blank before it cuts a sufficient thread to pull itself along. The adjusting screws allow the die to be compressed or expanded to accommodate slight variations in size, due to material, manufacture, or die sharpness. Each tool is used independently, but are usually sold in paired sets of both types, 1 die and 3 taps. Some sets may provide a lesser number of taps. The common sets shown are designed for hand operation, but different types such as helical or spiral may be used in production tools such as CNC machining tools, which employ die heads to make large volumes of threaded parts. Die nuts, also known as rethreading dies, are dies made for cleaning up damaged threads, have no split for resizing and are made from a hexagonal bar so that a wrench or shifter spanner can be used to turn them. Die nuts cannot be used to cut new threads. Lubricants. The use of a suitable lubricant is essential with most tapping and reaming operations. Recommended lubricants for some common materials are as follows: carbon steel, petroleum-based or synthetic cutting oil. Alloy steel, petroleum-based cutting oil mixed with a small amount of kerosene or mineral spirits. This mixture is also suitable for use with stainless steel. Cast iron, no lubricant. An air blast should be used to clear chips. Aluminum, kerosene or mineral spirits mixed with a small amount of petroleum-based cutting oil. In some cases, products such as WD-40, 5 Costa Rican colons to 56 Costa Rican colons and 3-inch 1 oil are acceptable substitutes. Brass, kerosene or mineral spirits. Bronze, kerosene or mineral spirits mixed with a small amount of petroleum-based cutting oil. References. Bibliography, DeGarmo, E. Paul. Black, J.T. Cusa, Ronald A. Materials and Processes in Manufacturing. Wiley. ISBN A0-471-65653-4, Rowe, Joseph Wickham, English and American Tool Builders, New Haven, Connecticut, Yale University Press, LCCNA 16011753A. Reprinted by McGraw-Hill, New York and London, 1926. And by Lindsay Publications, Incorporated, Bradley, Illinois. External links, photo of a hand tapper,